Hi guys, this is Mr. Y, and I'll be out sick today, so I created this quick video to help you review briefly before the test, which is also today. So let's start with arithmetic and geometric sequences. The formulas are for recursive. Remember, you start with f of 1 equals whatever the value of f of 1 is, and then f of n equals f of n minus 1 plus d for n greater or equal to 2. And then for explicit, so don't forget these elements of recursive, okay? There's f of 1 first, and then f of n equals f of n minus 1 plus d. If d is positive, it will be a positive number. If d is negative, the common difference, then it'll be a negative number. And don't forget the f n greater or equal to 2. For explicit, it's f of n equals f of 1 plus d times n minus 1. All right, and then an example on this is, so you see 17, 11, 5, and negative 1. From 17 to 11, you subtract 6. From 11 to 5, subtract 6. If you subtract 6 again, you get negative 6, you get a negative positive 1. The common difference here is negative 6. So how do you write these rules, right? For recursive, if I were to write the recursive, I would say f of 1 equals, and I state f of 1, which in this case is the first term, and that's 17. And then I would say f of n equals f of n minus 1 plus the common difference. Now the common difference is negative 6, so minus 6, and then comma for n greater than or equal to 2. So these are the elements of recursive. For explicit, I would say f of n equals f of 1, the value of f of 1. Don't just write f of 1, write the value of f of 1, which in this case is 17. And then plus the common difference is negative 6. So you're going to say negative 6 times n minus 1. All right, and this is how recursive and explicit formulas for arithmetic work. For geometric, it's very similar. For recursive, you state f of 1, then f of n equals f of n minus 1 times the common ratio now, and also for n greater or equal to 2. For explicit, you would say f of n equals f of 1 times r to the n minus 1. For example, example 3, you go from 3 to 12 to 48 to 192. Notice that we're multiplying by 4 every time. So our common ratio, r, is 4. So therefore, the recursive formula for that becomes f of 1 equals to 3. The first term is 3. F of n equals f of n minus 1 times, what are we multiplying by every time? We're multiplying by 4. So let's multiply by 4, and also don't forget for n greater or equal to 2 after that. That's for recursive. For explicit, we would just say f of n equals f of 1. You state the value of f of 1, which is 3. And remember, I always encourage you to put r in parentheses. So r is the common ratio, which is 4 to the times 4 to the n minus 1. You want to put a dot before that, that's fine. Just don't multiply them, right? The 3 and the 4, they just stay like that. And that's explicit. Now, let's go back to arithmetic. A cab driver charges a flat fee of $3, and then a $2 per mile driven. Complete the table. So I did not put a table, I'll put it here. Let's say on the table of values, this will be given to you. Let's say n and f of n. And we're saying in this table, we're saying the first mile is how much. Remember, he charges $2 per mile, but he had charged $3. So this is probably going to look something like this: 1, 5, right, 2, 7, etc. So that means we can go back to the zero term. If there's no miles driven, this is where our flat fee, or the $3 of a flat fee, is from, right? So complete the table. The table will probably, again, I completed it for you. You may be given maybe 5, right? And I'd say this. These will be blank. So if you're given 5, you just add 2 every time, because you know this is your jump. It's $2 per mile. For part B, what does f of 5? If I were to go one more unit here, let's say, that's 5. What does f of 5 mean in the context of the situation? So remember, when they say context of the situation, that means you need to tell me in words, right? What does this mean? So I would say for 5, or to drive or for a 5-mile ride, right? It's better. For a 5-mile ride, the cab driver will charge, and how much will he charge? Or she charges, they will charge, if you add 2 to 11, $13. Okay, and you can complete that in the table, which is going to be here. Okay, so that's what it means in the context. Make sure you don't say the amount of money that he will charge. Just say exactly what it is, which is 5 miles for a 5-mile ride. He or she will charge $13. So specifically state that. Example 4, it says f of n equals 9 multiplied by 3 to the n minus 1. And then the question says, write the corresponding recursive rule. So for the recursive rule, we want f of 1 first, right? So recursive rule. What is f of 1? So I would normally put it like this. F of 1, you plug in 1 into the equation. F of 1, be careful, f of 1 is 9 multiplied by 3 to the 1 minus 1. Now, no, f of 1 is also this number, right? We know that. We know that's f of 1. But here, if you plug in 1 into the equation, you'll get 9 multiplied by 3 to the 0. And 3 to the 0, we know it's 1. And 1 times 9 is 9. So that's another reason, right? But we know f of 1 is 9. And then f of n, remember we're doing recursive, is equal to the f of n minus 1. And then what are we multiplying by? We're multiplying by 3. Remember, in this formula, this 9 here is your f of 1. That's your f of 1. And the 3, that's your common ratio. So again, sorry about that. F of n equals f of n minus 1 times 3, comma, for n greater than or equal to 2. Don't forget that part, right? Now, example 5, it says f of 1 equals 12, and f of n equals f of n minus 1 multiplied by 1/3, let's say, for n greater or equal to 2. So then it says write the corresponding explicit rule. So explicit rule says f of n, remember this is geometric, right? Because we're multiplying. And geometric says this for explicit. This is explicit for geometric. So you're going to say f of n equals f of 1, the first term, which is 12, and then multiply by the common ratio, which is 1/3 to the what? To the n minus 1.